Welcome to Transmissions from the Tweet Factory, how observability transformed mobile performance at Twitter. I am your host, Hanson Ho. I use he, him pronouns. For those of you just listening, I'm a Chinese-looking guy, bald, glasses, a bright yellow shirt. I work for a company called Embrace. We do observability, mobile observability, built on open telemetry. And I can talk about the Tweet Factory because in a previous life, I was the tech lead for the Android performance team over there at Twitterland, twitter.com, hell site. But I am no longer associated with that entity for reasons you might guess. But I can still talk about it. 7 years spent there. I remember what happened. So let's go back in time, shall we? Remember 2015? Ah, yes. For those in the US, remember the New England Patriots winning the Super Bowl that year. Closer to here, just north of London, Watford promoted to the Premier League. Fantastic achievement. And Twitter, the micro-blogging site, had about 150 million DAUs. They seem like a lot, but execs and shareholders weren't happy. They wanted more users specifically. Users. And back then, what they did was they hired people to do work. So we recruited folks like me to work on the mobile apps, for me, Android, because I know Java. Our job was to improve app performance in order to drive user growth, because back then, if you don't remember, if you had the Twitter app, and your phone isn't great, or it's running on a 2G network, the app just didn't work very well. And the execs and then the engineering team thought, if we made it better for those folks, maybe it'll bring all those users they wanted. So what we did was we built features for those low-end devices and networks to work better. We ran A/B tests to actually verify whether they're good or not, and we shipped the features that made things better. Now, what do I mean by better? Well, back then, better just means product metrics went up. Product metrics are the things that track user behavior. Things like DAU, revenue, tweet impressions, things that the business cares about, things that brings revenue. And more DAUs, don't forget, that's what we wanted. Make all those people with low-end phones on crap networks, make them be able to use Twitter. All right? But us as engineers, we need something a little bit low level. We want to measure things that may not necessarily move the big needle, but the small needle, improve app performance. That's what it's all about, right? But at that point on mobile, Twitter did not have any perf metrics. We had crashes, but not much else. So we built some. Well, because at Twitter, there's tons of backend infrastructure for us to leverage off of, we use and borrow something they had in the backend already, something called PerfTown. Well, PerfTown is just a simple structured log system with some context added to it. It allowed us to do durations and counts and basically metrics. Yay, perf metrics. Now we have some of those, eh? We can count durations of operations, network latency, frame drops when you get jank on your screen. It's because certain frames were not sent to the main thread in time to be rendered. Data usage as well. If we want to cache data, if we use too much data, that's bad. We want to know that. So we built features. Network latency improvements, for instance. Back in 2015, HTTP2 wasn't that common out on mobile apps. Well, we did it and we measured it. App optimizations like startup time, like pre-warming Chrome process, which was my first feature there, pretty cool, and prefetching content. Imagine if you had data cached on your phone when you woke up. That may be enticing for you to use the app more, right? Well, thanks to those metrics, both perf metrics and product metrics, we were able to evaluate this, look at the experiments, and found some of them to be good and some of them not so much. But basically, the metrics confirmed the impact of changes that were large, that we thought would move the needle. We thought that we could show in an A/B test statistically significantly moved metrics in a positive direction. Over the years, perf metrics improved. MDAO, monetizable DAUs, improved as well. We got more users in because those with the crap phones, they can use it now. And somebody made money, some more than others, but you know. But things got hard when the low-hanging fruit was all gone. All the easy things were gone. And showing impacts for smaller changes was harder. We needed to sample differently. We need to be more sensitive. We need to do things that were time-consuming to show impact. Learning and iteration is time-consuming. If you wanted to add instrumentation to learn something new, well, it took 15 minutes to change the code, but maybe a month for the thing to get out to users, because you have dog food, alpha, beta, you got the Play Store and the App Store waiting. Even Twitter had to wait. And then, once it was released, 24 hours, 1% rollout, and then another week to get up to more than 50% adoption. And then up to 2 weeks to collect more data. So basically, from the time you're asking a question to when you actually find the answer, 5-6 weeks, it made learning extremely time-consuming. And you forget, what did I want to know? Oh, okay. All right. 6 weeks. That sucked. We had mobile monitoring. It was good. We can verify features. But we did not have observability. And that's what we needed. Twitter was getting away with it for the first couple years with mere metrics. And it worked until it didn't, until we ran out of the easy things to do. So how did we solve this? Well, let's fast forward in time, okay? Let's pretend it was the year 2019. 4 years. The Patriots won the Super Bowl again. Watford made the FA Cup finals. Don't ask us what happened in the finals. And Twitter, great time as well, because we finally started tackling mobile observability. Except we didn't know what that was. There was just things that we thought were missing. Well, what was missing? Dynamic slicing and dicing of data for us to learn from the data without shipping new instrumentation. We also couldn't directly link perf to user behavior. What does it mean when P75 of app startup went from 3.2 seconds to 2.9 seconds? In that experiment, certain things happen, but those are correlation, that's not causation. We don't know what to prioritize based on the experiment. We need something that linked the two together more directly. The thing we're using, PerfTown, it was insufficient. We needed something new. So you might ask, well, why not OTel? Remember, it was 2019. OTel was just beginning. Sure, there were other standards, but what we needed wasn't easily available. Why not Zipkin? Twitter made Zipkin. Why didn't you use it on your apps? Remember, it's mobile. Things like that are designed for backends, and there didn't even exist SDKs in iOS, at least not in 2019. Maybe now, I don't know. But we're basically stuck, and we had to build something new. Enter production client tracing, what we called PCT. So it is exactly what you thought it was going to be. It looks a hell of a lot like OpenTelemetry tracing. And in fact, if we were to start today, that's probably what we used. You got spans, you got child spans, you got context, good stuff. But we had to optimize it for mobile and web. What did that mean? Well, what we're modeling were traces, but not of the app execution. No. The start did not come when a request came in and a response going out. The start was when the user did something. They pulled on the tab to refresh. They clicked a button. We were tracing their heads. And that is a different mental model. That is a different cadence. And the platform had to deal with that and support it well. We also had to design everything to work in this hostile mobile use case, where apps can crash at any time, apps can be terminated at any time, and you can lose network connections at any time. So things have to be durable and resilient, and also use as little resources as possible, both in terms of serialization, persistence, marshaling, networking, everything. Minimum, because Android Go phones that cost $50, they can't really handle much overhead. And we also needed to link context from other sources in order to create more dimensions to filter and slice and dice by, because we can't write everything on telemetry. It gets to be too much. So we did the thing. Big tech, but small team, one per platform. Shout out Jeff from iOS, shout out Justin Trobeck, who may be listening. In the back end, Justine on web, and myself on Android. And we built PCT on existing Twitter infrastructure. On the back end, it's things that I know nothing about, like Kafka, Druid, GCP. On the front end, it's existing libraries that we use for collecting analytics. And we re-instrumented the mobile app as well as the web app for key workflows for which this would benefit. Using PCT, we know when every operation that started, when it ended. And we have a web UI for slicing and dicing. We're able to take that data and actually use it. So there were some challenges, obviously, trying to roll this out, tracing on mobile, because tracing is actually a foreign concept to a lot of mobile developers. Spans is not in their vocabulary because production data is foreign to them. Maybe we have some product analytics, but they may not even be doing that. So explaining the whole notion of trace is a tree and spans is spans, that's not automatic. Operations also cross boundaries in terms of teams and modules. Remember, the operation starts when you click a button, and it ends when you get value from the screen. So it could go through multiple threads, multiple components, and we had to make sure things all worked well, and the instrumentation isn't broken and brittle as things change. That is a technical problem, but also an organizational problem. Also, instrumentation overhead can be extremely harmful. If you log the wrong place, too much volume, you can actually make the app worse. Ironic, isn't it? You want to make it better, but you actually make it slower because you're capturing all this data. So, did this work? Did this improve things for mobile developers at Twitter? Well, I mean, I'm here talking about it, am I? So let's fast forward in time a bit, okay? This is 2022, specifically the middle of 2022. That's important. Things weren't going very well that year. The Patriots didn't even make the playoffs, let alone win the Super Bowl. Watford were relegated to the Premier League, again. But Twitter, well, at least on mobile, in the middle of the year, things were going pretty good. Mobile Ollie was being established. The challenges I talked about before, partially mitigated. What we did was add higher level abstractions so people don't have to deal with traces in the raw. They just dealt with these state machines and fired events, and that took care of the logic. The threading, the parent-child terminations at weird times. It helped instrumentation when folks don't have to deal with the complexities of managing complex traces. We also issued guidance in terms of what should be instrumented and what shouldn't be. Measuring the 10 milliseconds it creates to render a frame, not what this is used for. User operations, maybe even network requests. That's what we're talking about. You don't want to add overhead that is significant when you're tracing something. So, what actually changed at a high level? Well, we enabled learning from the data. We got observability. I mean, Hazel's definition of asking questions, getting answers, and meaningful impact, we were able to do that. And let me illustrate that with a little story. So there was a particular app version that was a couple years old, but it was, for some reason, overrepresented. There's like 50,000 users every day. We had no idea why. Well, it turned out it was a particular app version that was pre-installed on some phones sold by a specific telco in Japan. And that's why it was always appearing, because people reset it to factory defaults or just didn't upgrade because of whatever reason, their corporate phones, who knows. But it allowed us to make a decision to ignore it a little bit, or at least not deal with it as if it's an urgent priority. And we're able to find this not randomly, because who would instrument that specific set of attributes together? You needed first version, and then go down to the locale, and the phone model, and then the fact it's pre-installed. You need observability to answer these types of questions. And this and more we're able to do on mobile because we had actual observability. The second thing we learned, or rather that happened, was iteration on mobile became a lot faster. So not only did we learn from the data and be able to not have to experiment and roll out new changes to get new data and learn from it, we were able to find a new golden metric. One that is more sensitive to perf changes than regular perf metrics, and one that is more closely related to product metrics. This is exactly what we wanted. Well, what is it? It's something boring. It's just user operation failure rate. But on the client side, this takes on a slightly different meaning, because this actually measures how many operations started by a user that didn't complete successfully, an individual user, a user perhaps on a low-end device. Because failure rate is just incomplete over attempted. This is y'all know this stuff, but again, on the app, it means something different. And why is it so great? Because user expectations for performance are factored in. Because on the client side, performance is a spectrum. It is totally dependent on user expectations. What I think is fast is not what you think is fast. It's not what some person in a farm with a low-end phone on a 2G network thinks is fast. 20 seconds, intolerable for us. 20 seconds, worked. That's awesome. Success rate or failure rate factors that in. It either worked or it didn't. It's basically a product metric. Did the user get value? Or specifically, did the user get value when they wanted value? And the inverse of that is, did they not get value even when they wanted value? Because what are failures? Well, the first bucket of failures is bugs. During an operation, it crashes, you don't complete it. Another bucket, user changed their mind. Notification, I'm gonna go read this notification, forget about whatever I was doing. These things are uncontrollable, not really related by perf. But you know what is? Abandonment. If you thought an operation took too long and you give up and you're impatient, you don't complete your operation. The metric gets a little worse. Well, if it gets a lot worse, you're gonna notice. Abandonment basically is caused by bad perf, normalized against user expectations. Failure is basically some stuff and bad perf. Failure is directly related to bad perf. Failure is directly related to some perf, ding, 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 fa, 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 fa. We have this awesome thing now. It is a metric that is both perf-based, but model user behavior. It is from the perspective of the user. As my colleague David Rifkin always says, it inverts the whole instrumentation process. You're not observing the app, you're observing the user, the app, the performance. That is just trivia. Forget perf. Who cares what the number is? I mean, you do care, but you care that the operation completed. So forget perf. Did they do the thing or not? If they did the thing, it was fast enough. If they didn't do the thing, it was not fast enough. You don't have to worry about the millions of different users using different devices, different networks, different expectations. What does P75 mean? I don't know. I know what abandoning an app start means. it means they didn't finish. They didn't get value. Failure rates are user-centric. Ollie derived from failure rates then becomes user-centric. Twitter, at that point, had user-centric observability. On mobile, this was 7 years ago, it didn't even have perf metrics, and they had mobile observability. That's amazing. You would think they would just use this and do a lot of awesome things to it. But then what happened? Oh, I don't know. Something happened. It's not really important. 2022, mid-2022. Let's stay there. The rest, let's not worry about, okay? So, takeaway. What do I want you to take away from this session? Well, Twitter was changed with user-centric mobile Ollie. The way we worked, the pace at which we worked changed. The things we could do, the things we can answer with data changed. User-centric Ollie can change your world too. But this is 2025. We don't build our own thing. We don't have to. Open telemetry is right there. Now, is it perfect for mobile? Maybe not. Does it work? Absolutely. And there are people in this room right now trying to make it better and better for mobile OSs and platforms. If you're working on React Native, there's something in the pipeline. If you're working on Kotlin multi-platform, well, just wait a couple weeks. Things are going to get better in this space. So if you were to take away one thing from this session is get yourself some Molly with open observability, open telemetry. That's Molly Rankin from the great band Always. When you think about her, when you see the telescope, you think, what I need on my mobile app is some observability. Get yourself some Molly. Actually, the real takeaway is this. I didn't think I had time, but I do, so here you go. Cameron Hurley, great science fiction author, said this. Sometimes we are, well, there's a quote from Audre Lorde, she's awesome. American poet, activist, all-around intellectual. Sometimes we are blessed with being able to choose the time and arena and the manner of our revolution. But more usually, we must do battle where we're standing. You can apply this to many things, but for observability on mobile, just do the thing, do anything. Don't wait for the SDK to be perfect. Just make sure you don't kill perf. Do something. Get Molly now. Thank you.